Hello, everybody, and thank you for joining Service Virtualization for Dummies. This is part of the Innovate 2013 that was presented in Florida. We're doing a replay today, a live replay with Alan Wagner as our presenter. This replay is live, and we will be taking questions through the chat. Please feel free to come up with your questions as we do the presentation. It is being recorded, and the presentation will be available after the session on the website that you took to get here. Thank you, everybody, for coming. Our presenter today is Alan Wagner. He's a technical marketing manager for IBM Rational, and he's an expert for service virtualization, and he's presented this presentation quite a few times. So we're hoping for a great session, and thank you again for joining, and please be on the lookout for the replay.
Thank you, Cesar. Can everybody hear me okay? Cesar, can you confirm that my phone line will be going out on the audio?
Yes. Let me do a quick test. If everybody can hear me, just type okay in the chat.
Okay, great. So thanks very much for everybody listening. As Cesar said, I have delivered this session a number of times, and as part of this book that we created published back in January of this year, it was myself, Peter Klenk, Cherie Bergeron, and the two people listed on the cover, Marcia Kaufman and Judith Hurwitz from Hurwitz and Associates, who really put together this content. And what we're going to do in this 45 to 60 minutes of time that we have together is go through the highlight and call out certain areas of the book or the certain key messages or takeaways from the content available in this book. Now, the URL at the bottom, it's not a typo. It is ibm.co/service virtualization. It's a shortened URL that will take you to the service virtualization main pages on ibm.com. So, what are we going to talk about? Well, first, let's define what service virtualization is all about. Then let's look at, what is driving things in the market and establishing a need for service virtualization. We can look at the past, how we've approached testing. Then we're going to start to get into how to get started with service virtualization, putting it to work, and then share some details on the value that you can get out of it. And then finally, we'll close out on the 10 key things that we've identified that we really want people to remember from this material. So, what is service virtualization? Well, according to Wikipedia, it's a method to emulate the behavior of specific components in a composite application built on service-oriented architectures or business processes. And it's really used to provide software development and teams access to these dependent components that may not be available when they need them. Basically, you're simulating the behavior and the functionality of software and services or systems so that you can begin testing earlier. What we're really saying, or how we are defining it, is simulating the behavior, both the functionality and the performance of that select component within an application to enable end-to-end testing of the application as a whole. And that's important. It's not just the functionality, but you're able to simulate the performance. And again, it's still giving the QA and development teams access to these dependent components that may not be available for them. So, now that we've defined it, let's see what it can help you do. So service virtualization enables you to create these virtual components, which again can simulate the behavior of an entire application, a system, a specific service, a piece of software. They can be running on commodity hardware in private and public clouds. So, if you look at a mainframe environment, very expensive to set up, very time-consuming to set up, we can virtualize components of the mainframe implementation, the services or the software running on the mainframe, and simulate on commodity hardware in a private cloud or in a public cloud. And what this allows us to do is it gives each developer, a tester, their own test environment virtual component that they can work with so that they can test the integration between the code they're working on and the dependency they have within the overall application. Now, this doesn't mean that testers and developers have to change the tools that they're using to test by. We can use these virtual components to simulate these dependent pieces of functionality for manual testing, performance testing, or UI test automation. So they can continue to use the testing solutions that they have in place, or the processes and the procedures that they have in place, leveraging these virtual components, again, with the end goal of starting to test earlier and testing more often. Now, a lot of people may look at virtual components and say, we're already using mocks, or we're writing our own stubs through custom code or whatever. And really what a mock is, if you're not aware, is it's a piece of code to stand in for that other piece of functionality. So if I'm going to make a call to something, I might create a stub that will emulate that functionality. And again, it's very similar to a virtual component, where it's able to simulate the behavior of the existing code or be a temporary substitute for that yet-to-be-developed code. However, this approach can be labor-intensive. You're writing more code. It's taking time away from the developers doing what they're supposed to be doing, and that's writing code to generate revenue for the business or solve a problem. Writing these mocks can require deep knowledge of the technology that you're implementing on and the business logic that you need to be emulating. It's going to require some configuration management of the stub itself so that you have version control around them, as well as when I deploy these stubs and that real code comes available, it's probably going to require me to change my application configuration when I'm switching from that ad hoc mock to the live service. And mocks created by developers to help them with testing aren't really shareable across the enterprise, meaning that they've probably written that mock to meet their needs, but perhaps not the needs of everybody else on the team. And that's where the virtual components come in, and using a vendor solution, they're able to be deployed across the enterprise so that everybody can leverage these virtual components. And it's giving back the time to the developers to be writing the code that is required by the business. So, that's really what service virtualization is all about. It's the simulation of dependent software that you may not have available to you at any time, or you could simulate expensive systems like mainframes or time-consuming to stand up. It's really about simulating the functionality in your test environment. You're able to stand up these test environments faster and at a lower cost. So let's look at looking at the past. Why is there a need for these virtual components and service virtualization? Well, the applications today are changing. They're becoming very complex. You've got a user interface that could be presented in a traditional laptop or on a PC, desktop PC. It could be on a tablet interface. It could be on a phone. And a lot of these applications are still connecting to this back-end system. So we've got multiple layers of technology. You could have SOA, EAI, or BPM implementations that are engaging a number of different vendor platforms, performing complex transactions with dependencies on all of these back-end systems. And if we look at it, an application today, we look at a banking application or a travel reservation application, there'll be some marketing stuff. So maybe it goes off to a marketing application and pulls back some information based on data that's been captured around that particular user. It might engage a flight reservation system that's offered by a third party that I need to pull some information back to that. It could be a payment processing system where I'm going to have to interface with a credit card company to process a transaction. If there's changes to all of these different systems, Or if I need those systems in a test environment, I might not have access to them when I need them, meaning that I could have delays or testing bottlenecks in my and slowing down my testers' ability to validate today's application end-to-end earlier. And then we look at contesting these complexity is hard. We go to stand up a test environment. Perhaps I've got to wait for somebody who's got the mainframe skills, or perhaps I have the mainframe skills to stand these pieces up, but it's taking time away from me doing what I was hired to do, which is test the application. These teams are getting, bigger. The development teams are getting bigger, and they're more geographically dispersed. And typically what happens when these bottlenecks show up around the test environments and standing up these environments to validate the development effort, testing will be deferred or descoped or delayed, and what organizations will typically do is bring in more people. Well, the cost of labor is increasing, so it's not only the effort and the dollars spent on standing up the environments, which is causing, driving up the cost of testing and delaying the team's ability to test, but adding more people to it is driving up the labor costs and increasing the overall cost of testing. Now, the other thing is that, we're moving, so many teams are adopting Agile, and we're moving towards this continuous testing where on each check-in, the application is built, the tests are run. Well, what if all those pieces that you need to test that application, all these integrations aren't yet available? Many teams will descope or defer testing of that functionality until that piece of code is available. What we're saying here is virtual components can be used to simulate that functionality until that piece of code is available so that we can do that continuous testing all of the time. So, if we look at it, unfortunately, we're still testing in many situations the same way that we have in the past. We're coming into the application through a user interface, whether it be through a mobile UI or a smartphone UI or a laptop or a desktop PC, interacting with the user interface, and underneath that surface is all this complexity. So if we were go to test some functionality in a UI, and we get an error message along the way, or we're missing a piece of functionality, we're going to get an error message. When we go to submit a defect, we're going to say, I was performing this particular test case, and these are the steps to recreate it, and I got this error message. Well, when that goes to the development team, they have to start to triage things. But if you look at service virtualization and being able to implement virtual components to simulate, the missing functionality, now we can start to get to that integration testing piece and validate the request and the response. So the request is sent to the virtual component. It looks at the request coming in and delivers a response and validate that response between these two components. So now we're able to test at an integration level and simulate all these different dependencies much sooner so that we can isolate defects for faster remediation. So what we really want to do is start to go into the white box testing and use these virtual components for this integration testing and get underneath the covers and know what's going on below the surface. So how do we, if we're looking at how do we get away from the challenges that we face today? It's some people will say, I can't begin testing until I have everything available. It may be too expensive for me to set up a live feed for a test. I might have third-party services that I'm dependent on. I can't get time on their test environments to start testing the integration between my code and the dependency I have on their implementation. Operations of the test teams or the development teams, we may still be waiting for the test environment to be deployed or the source code to be deployed to that environment. We could be waiting on some test data, or we could be waiting on budgets to clear so we can purchase new hardware so that we can stand up multiple test environments so that we have the flexibility to test what we want, when we want, how we want. And if we do have a test environment, sometimes it can take a very long time to refresh these environments. And then the last thing is maybe the development team hasn't even started working on the piece of code we need to start to test the integration and the application end to end very much earlier in the process. So what I'd like to do now is, and I'll typically run this poll question every time I deliver this kind of a talk, and I'd really like to know what percentage of your time are you spending up setting up, maintaining, and recycling your test environments? So we're going to start the poll, and I'm going to give you a few minutes to respond, please. I have 7 votes in, so let's give it a few more seconds, and if you haven't responded, please respond to the poll. Okay, well, we have over half the people have responded, so let's look at the results. Okay, this time I'm a little surprised by some of the results where we've kind of got a split between 0 and 20% of my time and 21 and 30% of my time. I typically see the 21 to 30% or the 31 to 40% being the highest levels, and then it's with a smattering of people in the other areas. I've never seen this one before. So obviously people have figured out ways to stand up their test environments quickly. Okay, so thank you very much for your responses. So one of the things that's really driving the need to get these environments available quickly and move the developers and testers to be working in sync is the transformation to Agile. Organizations have spent a lot of time getting their developers to move faster. And developers are cranking out code, and there's, nightly builds coming out or daily builds or hourly builds coming out, and they're being tossed across to the test team. And the test team is going to have to set up an integration test environment, take that build package and deploy it into their environment so that they can begin to test. And what we have seen in the past is that there seems to be a lag with the testing, because by the time the testers, it takes them a little while to set up their test environment, they deploy the code, they find some defects, it goes back. It seems that integration testing starts to lag behind the code itself. And I've seen this at one event where a team was talking about some of their testing challenges, and their solution was to defer the regression testing of iteration 1 into iteration 2. Well, that's defeating the purposes of what Agile is all about. And if you look at a model like that where I defer some of my testing of the iteration 1 code into iteration 2, if I find a defect in that code, then and I take that defect back to the developer, they have to roll back their environment so they can start to prove out what was the cause of this issue, and that's going to slow them down too. So we look at this. The developers are moving fast. They're writing code. They're creating nightly builds. They're putting them over to test. And then the testers start to, implement it into their test environment. They begin their build verification testing or some smoke testing or some functionality testing, and they realize the build's no good. And what happens when we get our developers and our testers out of sync, and there's delays in getting these tests running in sync with the development builds? What we say is when agility stops at integration testing, the entire organization is hitting the wall. And what we're really trying to do is move to a world of continuous testing so that we can accelerate software delivery and get feedback, continuous feedback, so that we can constantly improve the quality of the application. So with service virtualization brings opportunities to address some of these challenges. The inadequate testing and test environments. I will virtualize what I don't have. Defect escapes. If I start to automate my testing and use virtual components to simulate this missing functionality, that's freeing up my testers to do additional type of testing, like exploratory testing. That manual regression test, automate that stuff and use your testers' skills and get them thinking about, how that end user might interact with the application to discover those tough defects. We got test data consistency challenges. So, we can use these virtual components to improve our governance and control. We can, as a tester, we can set up, these virtual components to respond to specific message requests and implement those virtual components with the appropriate test data so that we're consistent in our testing. I talked about the escalating labor costs and the escalating costs of the infrastructure required to stand up these environments. Using virtual components, we can simulate that and we can reduce those costs. We can through automation testing and testing earlier, because we have these dependencies available to us. We don't have to bring on these people late in the testing phase to make sure we've tested everything before we go live, because we've been testing all along. We're able to isolate defects through integration testing and using virtual components so that we can decrease the cost of those defects, and we can discover those defects earlier in the process. Poor asset utilization. I'm standing up multiple test environments if I'm lucky enough to have the funding in place to do that. But then when I'm not testing, they're going to be sitting there idle. Well, with virtual components, I can turn on these pieces when I need them to simulate that expensive hardware, the application of the functionality implemented on that expensive hardware, and I'm getting improved asset utilization. And all what we're trying to do here is, again, through this testing, earlier testing, more often testing continuously, is we're decreasing that cycle time, and we're improving the utilization of the resources. So let's look at how do we get going and finding our way. One of the things I'd like to do is run another poll question here is, I talked about earlier where some people are writing mocks or some people are descoping and deferring their testing until the code's available. What I'd like to do here is understand, for those on the call, what are we typically doing in our organizations to, oh, sorry, we've got the wrong poll question here again. Cesar, what do I do here? I'm getting the wrong poll question.
There should be the other one right below it.
Okay, so here's the second poll. So please respond to this one. We're looking at how are you dealing with testing bottlenecks due to unavailable or missing software and services. Okay, we'll give it a couple more seconds. Okay, people are obviously, I would be interested in hearing who has shared that they were, manually writing the stubs. I'd like to, reach out to you on outside of this call to see how that's working for you, and I'd really be interested in understanding the one individual who selected none of the above. I'd like to know what they are doing to get around some of these testing bottlenecks, or perhaps they're not having any of these challenges. So let's go on to the next slide. So, how do we get going with service virtualization and developing virtual components? We want to look at where we're going to get the biggest bang for our dollar. Initially up front, get the low-hanging fruit. And one of the items we suggest in the book is to, when you're looking at discovering what to virtualize and you're trying to prioritize where you want to, which components you want to virtualize, we're suggesting to look at, a number of factors. What is the technology or the protocol or the message format? Is it, easy to simulate that missing functionality? So in this table, I've got a web service, SOAP over HTTP. The component name is our credit check service. I've got another web service, SOAP over HTTP, which is implementing the payment service. They're both a complexity to virtualize a score of 2. But the impact to my organization is that, the payment service is costing me $60,000 due to unavailability. The credit check service is costing me $10,000 due to its unavailability. So I'm going to implement a virtual component to simulate the payment service up front. Again, it's a relatively low complexity score, but the financial benefit to me, or the time savings benefit to me, is much higher than the other one. And when you start to determine what you're going to virtualize, we really recommend building out a table like this of all the different components in your system, understanding, how complex it would be to virtualize that component, and then understanding what is the financial impact, either through the infrastructure required to stand these up, or perhaps it's a third-party access fee that you have to pay each time you touch that transaction, or the cost or the time involved in standing this up. I just mentioned the third-party service. So a lot of our applications today are leveraging services that are provided by other vendors. And many of these vendors will have a pay-per-use fee associated to these types of services. Now, if I'm going to do a performance test, and imagine I'm looking at, running the test for 8 hours, and I got 50,000 users, and I'm looking at a transaction per second of 500. And I'm starting to touch that payment service, and I have to pay each time I touch that service in their test environment. That's really going to drive up the cost. So those are the types of things you start to look at when you look at the financial impact of the unavailability of that service, or perhaps it's a pay-per-use charge, or perhaps it's the infrastructure cost to stand up that environment. Now, once you start to determine these components that you feel that you will get tremendous value out of virtualizing to address some of the testing bottlenecks or the financial costs of the business, you got to look at what type of virtual component am I going to build, and what type of virtual component do I need to virtualize that real behavior. So, there's a number of different categories of virtual services available. Simple means I send a message in, and the virtual service reads that message, and it sends back a hard-coded response. The non-deterministic is I'm going to send in some data or some parameters, and I'm just going to get something back, a non-deterministic value, a hard-coded response, but it's going to be the same. Data-driven is I can send in, there's a variety of requests that could be sent to that virtual component, and the virtual component will then look at, an external data source and map that request to the appropriate response and send back that specific response before the request being submitted. Then I've been able to do stateful types of virtual services where the input and the output data are kept in a data model, and we're able to support create, read, update, and delete, and other stateful behaviors. And then the behavioral is, you're able to model the behavior of the virtual component to emulate or simulate some of these pre-packaged functionality like a shopping cart or a real-time data feed or a trading exchange. And you've got the flexibility within many of the solutions to create the right type of virtual component to emulate the functionality. So again, we're not only talking about, a simple send in a message and get something back, but these virtual components can become smart, and they can truly emulate the behavior of that missing functionality or that dependent functionality that's not currently available. So how do we create them? Well, one situation may be that I have them available to me in a production environment, or they're in a test environment that's already in place. And what I can simply do is listen and capture. And within the solution, you can turn on a recorder and be the man in the middle or be on the wire and capture the request being sent and the response that's coming back from that service or from the mainframe or from a smart device or from a database you've connected via JDBC. You can then take that and model it or modify it and enhance it to perform that additional type of stuff, whether it be that non-deterministic or whether it be that data-driven. And I'm able to create that. So that's a real simple way to do it is turn on a recorder, capture the request and the response, and modify it, enhance it to truly emulate the behavior. The other option is you can take the contract, the messaging contract of the design specification, such as a web service. The design teams, whether they're working across two teams or with another vendor, you're going to have the contract in place. You're going to understand what parameters are going to be sent and what responses are going to be coming back. And from that design specification, I'm able to turn that into a virtual component and, again, modify it to, be simplistic or non-deterministic or data-driven or behavioral. So, in finding our way, look at the table and prioritize where you're going to get the biggest bang for your dollar, what's going to take you the longest time to virtualize, get the low-hanging fruit, and get some value quickly. Understand that, there's different types of virtual components that can be created to truly simulate the behavior that dependent functionality that's not yet available will be delivering back and contributing back to the application. And there's again two ways to create them. You can record and capture, or you can create them from the design specifications. So, what's typically happened in the past is we look at a system where some requirements may have been captured. The development teams are out. They're creating their unit tests as individuals, and then we bring it together for the first time, and big bangs happen. The integration defects start to show up, or performance issues start to show up, and these can be very expensive defects to fix. It could require re-architecting the application or revisiting some of the design decisions, and it could really push a project back in time. So what we suggested with the service virtualization is the unit tests continue, but simultaneously, because we've got these virtual components that are emulating or simulating the missing functionality, we can do integration testing as well. So what that does is the unit test, the integration tests are running simultaneously. Because you've done more testing earlier and continuously, your system testing time frame decreases in duration. And your performance testing, which is usually the last thing that's done because you're waiting for all the pieces to be in place and you're waiting for all the infrastructure to be in place, it's going to happen in production. It may happen in pre-production, or it may be ignored. What these virtual components can do is you can shift that performance testing. In fact, we're shifting all testing towards the left so that we can shorten down the duration of the testing effort. So, virtual components, they're accelerating our testing, they're reducing our costs of infrastructure, labor, or pay-per-use charges, and it's lowering risk because we're getting continuous feedback on the quality of the code that's being implemented. So I talked a little bit about this at testing at every layer. So from the IBM Rational Solutions, we've got Rational Test Workbench that gives integration, functional, and performance testing. And we've got Rational Test Virtualization Server, which is the server-side deployment where we can implement or instantiate these virtual components to share them across the environment. Now, what this allows teams to do is I can start to test these integrations, and I can test at every layer of the application. I can test between the messages exchanged and the responses received between components, or I can test end-to-end from the UI down through the entire application, simulating the missing functionality with virtual components and validating that application end-to-end. Another technique in mobile may be I've got one team working on the mobile UI, and I've got another team working on back-end implementations or updates to my enterprise implementation. At some point in time, that mobile front-end is going to need to talk to that enterprise back-end. But with a virtual component from the mobile UI, I could simulate that back-end system, and from the people that are working on the enterprise, I could simulate the mobile UI messaging, so that I've got teams working in isolation, but they're in sync because they know the messages exchanged, the protocols, the technologies used, the formats, and when we bring them together, we've got a better implementation because we've been testing in isolation, but we've been testing the same type of message types, just using virtual components to simulate, that back-end system or the front-end system. And it helps when that integration comes together, the big bang issues are not there. So again, test continuously at every layer, whether that be between the components themselves, from the UI, or even the performance of the application. And the one thing I did not mention yet about the virtual component is, from a performance testing point of view, when we're bringing these pieces together, we're going to look at a service level agreement, and this component's got to respond in 0.5 seconds as part of the composite transaction. When we're looking at performance, we can tune these virtual services to simulate the latency as well, meaning that we can make that component respond in 0.5 seconds. We can make that component respond in longer than 0.5 seconds, or we could make that virtual service respond in less than 0.5 seconds. So we can start to test a bunch of scenarios, and I'll get to some stuff later, but I'm going to mention the term controlled integration right now. Rather than this big bang and bring everything together, we can start to bring the real functionality in a controlled manner, turn off these virtual components, and when that defect does appear as we've been continuously testing, we will know which component has actually caused the challenges that we're facing. So let's look at an integration testing by example. So I'm a developer. I've got to create module C1. But I have dependencies on an ERP system, a web service, and a database. And, I'm going to constantly be doing my unit testing, but I'm also going to be doing my integration validation with that ERP, web service, and the database systems. But that environment's not ready yet. So I'm going to use a virtual component to simulate that functionality so that I'm able to, test not only the method execution within my module itself, but the dependencies I have on other systems. So this is a quick setup. It's low cost. It's authored at the integration tests. Then I start to get more involved with the larger team. So I've got an integration with module C2 being written by another developer. And, I've been validating all along that my module is working fine with the ERP system, the web service, and the database, but when I bring in that other module C2, I get a failure. And it might be a blocking failure. And what could happen in that situation is I now have to wait for that code to get fixed before I can continue to, bring in more components in a controlled manner. With a virtual component, I can then virtualize that missing functionality, that C2 module, to simulate the behavior properly, which would allow me to keep moving forward and get to my first complete system test without having to wait for that defect to be resolved. And when it is resolved, I simply bring it back in. And again, I've been testing continuously that the impact is there is no impact. So basically, I'm able to leverage virtual components to get me around blocking situations that if a piece of functionality is broken, it's not doing what I need it to do, I can virtualize it using a virtual service, delivering the right functionality until that module has been fixed. And it just continues to go on. We're talking about that controlled integration. So after my first complete system test is working using virtual components, I start to bring in these components in a controlled manner. I'm still virtualizing the back end, but I'm getting closer to system integration and UAT testing. And I'm starting to execute against the live implementations. So, early on in testing, we're using virtual services, but we're starting to wean ourselves off of those virtual components as we get closer to user acceptance testing and pre-production. So, again, in the controlled manner, integrate with the expensive backends, minimize the use of backend systems for testing purposes early on. We're not saying that you're going to go into production testing only with virtual components, but these virtual components will give you the functionality or simulate the functionality you need to test end-to-end earlier in your processes. And through virtual components and injecting or implementing the real implementations in a controlled manner, and continuously testing, you can get easier and cost-effective defect isolation and identification. And if there is a defect that's blocking, you can use that virtual component to emulate that broken functionality that will allow your test teams to keep moving forward. So, I alluded to this in the last slide, but we look at virtual services implemented across the SDLC. So the developers can use the virtual services as part of the unit testing to validate the integrations with other components. The development and test teams can use these virtual services for, to shift that testing to the left and start to do more advanced testing earlier across the integration system and system integration testing phases. You're able to do that performance testing much earlier. Performance testing doesn't have to be a thing of a last minute or we don't have time or we'll test it in production. I've been on assignments where code has gone into production and the performance of the implementation was negatively impacted, severely negatively impacted. And then it became a question of keeping customers because the functionality or the performance that they were expecting was not there, and they were starting to look for other opportunities or other vendors to deliver the functionality that they needed. So that became very costly because as you start to lose customers, it becomes very expensive to get them back or keep them. And then, again, as we get towards the user acceptance testing and operability testing, we're going to start to wean ourselves off of these virtual services and validate against the real implementations. So part of this whole thing is that's great from a very phased approach in continuous testing, but we've still got these development teams that are, checking in new modules, builds are being created more frequently. We want to move to a continuous testing with service virtualization. And from the Rational Test Workbench, there's integrations with IBM Urban Code Deploy, where as part of this process, we're able to deploy the application, provision test data environments, and instantiate these virtual components so that as the build is brought into the system, it's automated deployment, it's automated test data is stood up, it's automated virtual components are put in place, and it's automated of the test being executed. And what this really does is it's truly moving us towards this notion of continuous testing and it's really freeing up the testers' times to do more advanced testing, or look for exploratory testing. The tests that are hard to write from a recorded point of view, but are really where the juicy defects are found. Getting into the mind of the end user and looking at the application. Does this make sense? Does this work? Is this doing what I expect or what the end user would expect? So this whole process of the combination of Test Workbench with the plug-in into IBM Urban Code Deploy, allows us to automate setup and management of test virtualization servers in the cloud. It allows us to automate the configuration of these virtualized services for an application under test. We're able to simulate that functionality, again, through these virtual components, and we're able to automatically stand them up as part of our deployment process. And we're able to set up production-like test environments at a much lower cost. Now, one of the things that people that shared earlier that they were writing mocks, the solution that IBM has in place is with these virtual components, as you toggle between the live implementation and the virtual component, you do not have to change your application configuration. So when we look at this continuous testing and look at solutions like Test Workbench and Urban Code Deploy, we're not only continuously testing the application code from very early on in the overall process, we're also testing the deployment because we're not having to modify these configuration files, meaning that my virtual my mock might be running on this IP address, but my live service is going to be running on a different IP address. My virtual component and my live service in this implementation would be running at the same location. So again, I'm not having to change that out. So let's talk a little bit about the ROI. There's an ROI calculator that Wintergreen Research has created for us, interviewing customers who are using service virtualization in their environments. And really the ROI is real, and it's quite substantial. But the main benefit area that you get from service virtualization is decreasing your hardware costs, decreasing labor costs, and helping to improve your defect removal efficiency. You're able to isolate defects faster for earlier resolution, and by isolating or identifying the defects earlier in the process, you're decreasing the cost of resolving those defects. Now here's a study of one customer that was Forrester did a total economic impact study on one implementation. And from a practitioner point of view, I was able to deliver more. We were able to scale up our project delivery capacity. We didn't have to hire more people because we were able to do our work within the time that we were given. The production incidents were reduced from 2.5 to 0.3 per project, which to the business is a savings in dollars. But from a morale and from a working in sync with the development team, it just creates for a better environment. They were able to identify the defects earlier. They didn't have to engage third-party testing fees or consulting fees, and they eliminated the need for additional hardware and labor. So, it's a lot of dollar savings to the business itself, but it also makes for I'm able to do what I was hired to do. I'm able to test the application. I'm not waiting for stuff to be available, or I'm not spending time standing up these environments. I'm able to create these virtual components, work my development team, test in sync with my development team, and if there is defects, discover them earlier when the developers are still working on that code before they move on to their next iteration. So, top 10 things to remember. Look at your approach to testing, whether it's manual or automated. We're looking at a way to accelerate this testing and make it repeatable and make it more efficient. Using that table, plan for flexibility. Look for the places where you're experiencing the biggest pain points and it's going to give you the biggest return on your time and investment. And constantly revisit that as your priorities may shift over time, so you're going to have to adjust. Practice the controlled integration. So, one customer at Innovate that in June of this year shared that in a performance testing model, they had an enterprise service bus, and they virtualized all the endpoints. And they were able to benchmark the system using these virtual components so that it met the SLA. And then they started to incrementally and in a controlled manner inject the real implementations and continuously run those performance tests. So when the performance tests, the SLA was negatively impacted, they knew which particular component was the bottleneck, and they were able to identify that defect, isolate that defect, and fix it quickly. We want to use virtual components to test continuously, right from development all the way through to production. Get the developers and the testers working in sync, and get that to done, done, done status in a single iteration. One of the top things to remember is externalize your test data. You want to decouple your test data from these virtual components that gives you added flexibility. I talked about that where in the creation process I do a record or a listen and capture of one transaction. But then I'm able to modify that test data or have somebody who's perhaps not familiar with the service virtualization tooling to modify an Excel file, a common delimited file that I can then bring back in and use that as my external data. What we're trying to do here is, again, through increased efficiency, is explore advanced test scenarios. We can do performance testing much earlier. We can simulate for negative testing much earlier. We can start to begin doing exploratory testing because we've automated the testing and leveraging virtual services to emulate the missing functionality. One of the things we suggest is don't reinvent the wheel. Don't waste time writing your mocks. Use a supported solution to increase team productivity. The developers and the testers have to write these mocks. It's another piece of code that you have to maintain and modify when changes come in. Use a vendor-supported solution because it gets the developers doing what they were hired to do, and that's write code to generate revenue for the business. And it allows these virtual components to scale across the enterprise and offer support to the larger team. So with that, service virtualization isn't just for testers. It allows the development team as part of the unit test to move beyond just method compilational type testing. I send some value in, and I'm expecting, I'm going to run an assert statement, and I'm expecting this return result. And maybe if there's an integration to a dependent component or a call to another component within that method, I'm going to ignore that piece, or I'm going to write that mock. Why? Use the virtual component to respond to that request so that I'm start to do a more complete level of testing during my unit testing and integration testing. Share these virtual components across the enterprise. These virtual components, we can isolate them so people can have their own little test environment using these virtual components, or we can have a service that's shared across the entire team. And this is a technology. It's not just install a test automation tool where I turn on a recorder and start to interact with the user interface, capturing mouse clicks and keystrokes. What we really recommend is investing time in building the skills around service virtualization, because that's going to pay dividends with respect to productivity. So with that, if you haven't got your copy yet today, there's the URL at the bottom on how you can go to IBM.com and find it. Again, that's not a typo. It's IBM.co/Service Virtualization for Dummies, proper case. Alternatively, you can go to the IBM.co/Service Virtualization, all lowercase, to take you to the main IBM pages where this book is also available. So with that, we have a couple of minutes. Is there any questions? And I'll watch the chat window here. So, Cesar, I don't have any questions. Have you had any questions come in?
Not seeing any. Looks like you were pretty thorough in your presentation.
You know, so to wrap up, folks, what service virtualization is all about is helping teams become more efficient, lower the cost of testing, and get developers and testers working in sync to achieve the ability to do continuous testing and get software to market faster. The business is going to make decisions on when we're going to release. The business, you know, has all that information, and they're looking for the testers to give them input on the status of the quality of the application. And it's up to the business to determine the level of risk that they're willing to take when they take a piece of code to production, you know, knowing what defects are currently in place and how severe they are. What we're trying to do is ship that testing to the left, test continuously right from the start. Let's not defer or descope things until they become available. Let's virtualize what we don't have and test end-to-end sooner. What that does is it's going to give you a higher level of confidence in the information you're giving back to your business stakeholders, and they're going to appreciate the fact that the application has been tested more completely when they have to make that decision of whether we're going to release or not. The business is going to be looking at the cost of testing. You know, if you can, instead of saying, you know, we don't have enough people or we don't have the time or we're going to have to cut these tests from our testing effort, you know, like I said in the service virtualization can turn challenges into opportunities. Be proactive with your stakeholders. Let's look at service virtualization as a way that we can, you know, not have to bring more people into test. Let's begin testing earlier. Let's simulate that missing functionality. Let's not have to spend millions of dollars in standing up our test environments or multiple test environments. We have the one in place. That will help us with UAT and system integration testing. But for earlier testing, let's use virtual components to emulate that functionality. So there's a lot of value in the service virtualization, and again, I hope you reach out to that URL. The one on the screen right now, the ibm.co/service virtualization, is the main page where you can also download the book. And, you know, please give it a read. The feedback we've got has been very, very positive on the information. There's been over 11,000 copies distributed to date. You know, and if you come up to the events that you know we're speaking at, whether it be the STAR events or the IBM events or some of the other external events, you know, service virtualization is becoming a very familiar term for many people now, and they're looking at it as a way to solve their testing problems and remove testing bottlenecks. So with that, I'd like to thank you for your time, and hopefully you'll pursue service virtualization further. Cesar, back to you.
Thank you, Alan, and thank you, everybody, for joining. Another great presentation, as always. This replay will be available on the website that you used to get here. The slides and the book, there's a URL to both of those on that website as well, so if you want to visit that to get to service virtualization as well. Thank you again for joining, and have a great rest of your day.